Good evening, my name is Cesar York. Today is May 2nd, 2020, and I'm going to be doing the third element of systems planning. I'm going to be talking about and presenting the third element of systems planning. Elements of systems planning. Element 3, systems planning is driven by natural resource availability. Table of contents. First is the glossary. 2. World mineral resources. 3. Forest change. 4. Global biodiversity. 5. Drinking water source. 6. Migration routes. 7. Global power plant fleet back technology. 8. Drought. 9. Fossil fuel consumption. 10. Ecological footprint, biocapacity deficit. 11. Water. 12. Ecosystem services. 13. City design and waste treatment. Glossary. Ecosystem services are the many and varied benefits to humans gifted by the natural environment and from healthy ecosystems. Such ecosystems include, for example, agroecosystems, forest ecosystems, grassland ecosystems, and aquatic ecosystems. Wikipedia. Ecosystem function is the capacity of natural processes and components to provide goods and services that satisfy human needs, either directly or indirectly. Ecosystem functions are conceived as a subset of ecological processes and ecosystem structures. www.un.org. Glossary. Biodiversity. Biodiversity is the variety and variability of life on Earth. Biodiversity is typically a measure of variation of the genetics, species, and ecosystems level. Terrestrial biodiversity is usually greater near the equator, which is the result of the warm climate and high primary productivity. So biodiversity is flora and fauna. Flora means that they don't live the way we think of something living, which are plants, flowers, uh, mushrooms, things like that. And then fauna, which any type of animal is fauna. World mineral locations. This is a map of world mineral locations. To your left, you have a list of major mineral deposits of the world: nickel, iron, aluminum, copper, lead, zinc, PG, gold, rare earths, diamond, clay, potash. As you can see, in South Africa, you have a lot of these minerals. You have high iron and gold. And in the United States, the west of the United States, you see there is more of these minerals. And in South America as well, to the west, it tends to be more minerals. In Europe and Asian countries, it seems to be more spread out. USA mineral resources. Mine, past or present producer, prospect or occurrence, processing plant, and unknown. So these are the mineral resources in the United States. So they're pretty much spread out, except in the center of the United States, there seem to be less mineral resources. That's what the map is showing. This is a map of the global forest change. All the areas that are shown in red, that means there has been a loss of forest. And this is a forest cover loss from 2000 to 2018. So the difference between those 2 years. As you notice, this has been a lot of forest loss in that time span throughout the world. Global forest change. Again, this is close up to the northeast section of the United States. As you notice, New York State does have a lot of loss in forest change. Well, all the regions close to New York State has had a lot of loss in forests. Global biodiversity. Globally, there has been an average drop in species at a local level of 14%. 14% is very important. You will learn later on why it's important. So in many areas shown on the map in red, biodiversity has dropped by 20 to 30%, whereas areas in deep blue, such as the Congo, may have actually had increase in biodiversity. So what does biodiversity means? It means that all these species, plants and animals, and how diverse they are in that place. So when there's less biodiversity, that means there are less varieties or species. There are less diversity species. So there might be only a few species compared to many of them. As you notice here, in the west section of the United States, there has been a lot of biodiversity loss. And then in South America, it's in the east section, it has been a lot of biodiversity loss or drop. And areas in Europe and India and south of Africa, all these plants and animals are either extinct or have lost a large population. Tipping point. This is important because 20% is widely considered a tipping point beyond which an ecosystem's ability to provide the natural services like flood protection or control pest outbreaks are compromised. For example, as biodiversity declines, outbreaks of crop pests become more likely. Anti-purpose. Though study lead scientists and museum biodiversity expert, we can spray crops and spend money to reduce that risk, but that is basically compensating for something the biodiversity used to provide before. Today there's a lot of monoculture. So they just grow, let's say, like only corn. And that has an effect on the soil and it has an effect on the ecosystem. There's no diversity there. And one thing about monocultures is that it's not sustainable. There's a lot of soil loss there. In natural ecosystems, there is a lot of animals and plants working together in order to create a system that is resilient, that's able to withstand phenomena like floods, hurricanes, and winds, and all these catastrophes that you see more now because of climate change. But when a place is diverse in flora and fauna, over time those areas become resilient. They're able to withstand change. So when you have less biodiversity, you actually having less places that are resilient to change. And one thing that people don't tend to focus on at times when having conversations regarding energy and fossil fuels is like not many people talk about marine systems. But there is a reduction of marine biodiversity because of human interactions with nature and also how we consume and what we consume. It has devastated the marine ecosystems. And here is a cumulative impact index map. So this shows you the areas where there's a lot of impact in biodiversity. As you notice in the northeast section of North America, there has been a lot of this cumulative impact. These biodiversities have been impacted drastically. That's what this map is showing. Figure 1. Global distribution of cumulative environmental impacts. Index of cumulative impact or equally weighted changes in SST, CHL, a proxy to primary productivity and ocean currents. Currents represent a dimensionless index of global impact, cumulative impact index ranging from 0, no change, to 1, maximum change, providing a measure of spatial heterogeneity in the magnitude of environmental change and highlighting these marine areas that have undergone the largest change in their environmental conditions. Like you see in this map here again, these areas in the northeast section of North America have been impacting dramatically. They are changing, and some of the systems might not be able to withstand this change or be resilient enough to withstand this change. And most of them tend to be in the northeast and European countries. That's what you see here. Biodiversity hotspots. 0 means no species. 1, you have a lot of species richness. This map shows you the differences. Here, the United States has hardly any species richness, right? In marine ecosystems. And then in South America, you don't have that many either. But when you go to areas in Australia, India, or the east section of this globe, you see biodiversity hotspots. That just tells you that these areas need to be protected. This diversity needs to be protected, so we have to find ways to protect these areas. The United States, because of its cumulative impact, it has affected a lot of these systems and a lot of this biodiversity. And some of these systems are being destroyed to a point that they can't exist anymore, they cannot subsist. So we have to think deeply of what we are doing in our countries, what are we doing in our homes, because the decisions that we make in our local communities affect many systems throughout the world, because it's cumulative. If we all do the same thing together, it has a global impact. Proportion of population using improved drinking water sources, 2012. Proportion of population. Less than 50% is orange, more than 90% is blue. Data not available. This map just shows you right here. South Africa is less than 50%. Have less or using less improved drinking water sources. So these areas have been affected dramatically. Right? In the United States, it's pretty clean. Most people get good clean water compared to other nations. But Africa has a lot of issues with water, and also with change or improvements in water sources. This is the migration routes of fishery throughout the world. You have all different types of animals, marine animals, that use these migration routes to move about. And through our shipping routes and through our ways of delivering products in marine areas, those ship routes and those boats and those whatever they are contaminating or devastating these marine ecosystems. And they are changing these migration routes for some of these animals through human impact. Most people in the United States and the world use electricity. So these are the fuel type, means the fossil fuels that are used in order to produce electricity. So they use these fuel types. They use biomass, geothermal, solar, wind, natural gas, oil, nuclear, hydro, coal, and other. So these fuel types is what makes electricity, or they provide electricity for all these places. Again, it's a constant trend through all these the United European countries are using all this electricity, they consume all this energy, they affect marine ecosystems. And so those countries have an effect in the global diversity, in the global ecosystems. And I mean, that country and the way I live, he also plays a role on what happens around the world. If many people live the way I do, that means I am consuming a lot of energy. I using a laptop here, I using my phone. So I'm part of this problem. But then we are so caught up in the system is how do you get away from that? That's a discussion that we need to have. What is the minimum we can able to take in order to solve all these problems? People say biomass is the way to go. No, when I showed before the energy return on investment, you don't get a lot in return from biomass. The most highest one, EROI, was about 1.7 to 1. That means you put 1 barrel of oil and in return you only get 1.7. That's not enough. And also it's very destructive to ecosystems. One thing that people use for biomass is corn. And so you need to have all this large production of corn in order to produce biomass. And that has dramatic effects on forests, on soil, on ecosystems. When you have monoculture, that means that soil depletes at a very high rate. And then when you have stormwater or you have any phenomena that they or rainfall, all this soil is depleted and it leads to desertification. Solar is not there yet. Solar uses fossil fuels in order to create these solar panels, and you require minerals in order to construct these solar panels. So to some extent, it's good, but a lot of it is not. It doesn't. The goods is different than the bads. The bads outweigh the goods. They are more. It tips more towards bad. Wind, the same thing with wind. Wind is not there yet. It uses fossil fuels. In order to maintain the systems, you got to construct them using plastic, metals, and then also to maintain them because wind only has a certain pattern. It has a certain wind pattern. So you don't get wind all the time. And then when those windmills are not working or they're not getting any wind, they just stop. So they're not producing any energy, and the way they keep moving these windmills is by importing fossil fuels. Natural gas is a fossil fuel, oil is a fossil fuel, nuclear has a lot of energy, but it has some major problems with architecture, with waste. It mainly is waste and location. These places or these nuclear plants require a lot of space, and if they are situated in vulnerable areas, it could cause a lot of damage in these places. If these are located in tectonic plates, in near tectonic plates, we have all these seismic situations happening, all these earthquakes happening, and then it could cause a lot of major problems. So many people say that the technology is there and it's more safer. Yes, well, that's what people said before when nuclear power plants were constructed in the 50s, 60s, and 70s. Yes. So the major one is really the safety issue and waste. And there is like climate change phenomena, like storms and then hurricanes and all these things. Those places are vulnerable. So somebody that tells me that is the way to go, no, I don't believe so. Hydro is the most safest out of all of them, but it still has some more problems with fisheries. Some of the fish, when they migrate, they get stuck in these hydro plants, or these hydro plants have effect on the migration patterns of the fisheries. And also hydro plants, the way they're constructed might have effects on rivers and lakes, and how they function. So they do have some limitations. Well, compared to the other fuel types, though, that tends to be the most safest one. Coal, nope. Coal is a fossil fuel. Oil, natural gas, coal take many years to make because they require geological processes over probably thousands or million years in order to make these things. And then the final one, geothermal. Geothermal is, I would say, second to hydro. It still has issues with earthquakes, seismic events. You drill down in a certain area, the certain areas that could be vulnerable. The rocks could be vulnerable, and then you might have some minor earthquakes. And it also affects groundwater. In New York City, it's underneath the pavement. There is groundwater, yeah, underneath those pavements. So you use this technology and dig there, it will have effects on the groundwater. All of them have effects, but two of them have less. The other one have way dramatic effects on global ecosystems, and also has more effect on climate change. National exposure to drought and extreme temperatures, 1986 to 2015. Number of droughts reported. So you can see in this world map, it shows all the dots on all these areas where you have the most droughts. So droughts have effects on earth ecosystems, and it has effects on forests, and also on soil type, or what happens to the soil. We have these droughts, and then these areas might become desertified or become small deserts. So droughts have a dramatic effect on ecosystems throughout the world. And what these maps, again, there are trends here in these global maps. Some of these places that are more affected with these things tend to be in Africa and South America countries. Oil consumption is measured in terawatt hour equivalents per year. So these are all the countries in the world. And again, the trend, I'm going to keep saying there's trends here. There are certain continents, certain countries that tend to consume a lot and take a lot of natural resources, and they have a high ecological footprint. And here you see the United States again. The United States has high oil consumption, right? And you go to South America, there's medium of it, there's less of it. And you go to Africa, you hardly see oil consumption at the level of European, Asian, Russian, and United States, and also Canada. Fuel consumption by fuel type, United States 1965 to 2018. So this is fuel consumption of the United States for those years. So you notice there has been an increase in gas. Coal has dropped since probably the early or the late 2000s, 2008, around there. It was high coal, and then it started dropping from there. Oil has increased as well. The peaks for oil were in the middle 70s. It was peak oil. So notice these trends, how in the lines, and you notice that they are peak periods. with these oils and also these fuel types. So over time, these peaks reduce and they start getting less. Fuel consumption by fuel type world. So oil has decreased a little bit from the 1970s. That means it's peak oil. That's when it peaked. In 1975, around there, you saw a peak and then an increase, and it's still increase in oil. Gas has decreased dramatically from the 80s to today. Coal as well in the world. So the world is leaning more towards coal and gas, natural gas. And oil has maintained a steady, but it still is growing. Production of fossil fuels. These are areas in the United States where there's production of fossil fuels. And then you can see one thing here that stands out. As you can see from this map, the Bureau of Indian Affairs and the Forest Service have a lot of land where there's production of fossil fuels. The Bureau of Indian Affairs is an agency that works with Native American land. So that means a lot of this land, Native American entities. So we are consuming fossil fuels. We are using fossil fuels that are being extracted for Native American lands for our use. And also the Forest Service means a lot of these lands are probably national parks or areas with high concentration of forests. So we are extracting from these areas in order for us to consume fossil fuels. U.S. energy consumption by source and sector 2018. And you can see here about, let me see, 25 and 13, that's about 38% is electric power sector. And then we have industrial, transportation. Those are the energy sectors that consume the most energy sources. As you can see from this graph, petroleum is about 36%, natural gas is 31%, coal is about 13%, and renewables 11%. Nuclear electric power is about 8.4%. So we need to change these sectors in order to reduce fossil fuel consumption because these sectors require a large amount of fossil fuels in order for them to run. Ecological footprint. In previous videos, I spoke about ecological footprints. So I'm showing this again. I can keep saying trends. In the United States, European countries, Asian places or Asian nations, Russia, per se, they have high ecological footprints. Biocapacity. The United States has high biocapacity. India, Australia, some South American countries have high biocapacity. Yep, but there's like an ecological deficit. That means the ecological footprint is higher than what nature could provide or biocapacity. The United States has a deficit, India has a deficit, Russia has a deficit, and North Africa has deficits. European countries have deficits. That means they have higher ecological footprints than biocapacity or what nature could provide. And here I'm going to talk about something very important. This is important for animals and plants. It has to do with how much of the water is fresh for our use. This is a conservative number. Here it says fresh water is about 3%, but no, it's lower than that. In global systems, it's about 1.2 around there. That is fresh water. 97%, around 97% is water that comes from the oceans. But this water we cannot drink. It's salt water. We cannot drink that water. 70% is frozen. But with climate change, these numbers are going to decrease when you gotta have this more melting happening in these areas. And then you have 22% groundwater, and then you have lakes, rivers, and streams. You only have 1%. So lakes, rivers, and streams is what is the storage areas of where we get our water. It comes from the lakes, rivers, and streams through ecological process and through geological process. This ocean water, frozen water, groundwater, it goes to these places and it starts purifying the water in order to be drinkable. So we have fresh water, so that's for the ocean, right? So some people say fresh water and then you have ocean water. When the two things are together, those are called estuaries. In New York City, you have an estuary. You have fresh water and then you have ocean water. But just know one key number there is 1%. That is how much water we have for us to be. That is how much the 1%. That is how much drinkable water we have in the planet. This is a hydro system or the water system. Here you have groundwater. At the bottom you see it says groundwater. That means the water seeps in. One term that environmental folks use is porosity. So when you have more porosity, that means the water is able to go through the soil and then go directly to the groundwater. We have rivers. So the rivers you get water from, in this case, from mountains. The melting of snow and ice. We have this water that comes from the snow and ice. Then you have fresh water. That's a mix. That means it's between ocean water and then earth side water. That's why I call it earth side water. So you have ocean water and earth side water. So fresh water are water that comes from rivers, lakes. So all this water is accumulated there, and it goes through rivers, and then when it hits the ocean, you have a boundary there that you have fresh water, so I call it terrestrial water, and then ocean water. So when that boundary is called an estuary. So in there is where you have a lot of this diversity or biodiversity. You have different types of species that live in oceans, and then species that live in fresh water. And here you have rainfall, you have evaporation, so you have the cloud. Something happens in the cloud with the chemicals, and then it rains. When it rains, it fills up again the rivers, the lakes, or it seeps into the water. Or it seeps into the ground and you have groundwater. Or in the case of New York City, there's no porosity because we have a lot of asphalt, we have a lot of concrete, so it drains directly to a water body. It could be a river or a lake. In this case, in New York City, there are rivers. You will go to the rivers. So there's no porosity, so it doesn't seep in, and that affects the groundwater. Top USA fresh water use. You have public supply. New York State uses a lot of it for public supply. You have power plants, irrigation, and industrial. The top two are for power plants and then irrigation. A large portion of the fresh water use is for irrigation. Right? In the north and southwest section of the United States is used for irrigation. So that could be cropland and agriculture, and also farms. A large portion of the United States uses fresh water for irrigation and power plants. I live in New York City, so New York City has pretty good water, tap water, so you could drink the tap water in New York City. Uh, why? Because of its watersheds or its lakes. So New York State has a lot of lakes in upstate New York, and those areas are protected. So some of these areas, nobody's allowed to develop there. Nobody's allowed to go inside, hunt or anything. So those areas are protected. So as you can see, he has a lot of these forests. So forests are helpful to maintain the systems. And they have all these lakes and rivers that feed into New York City. That's the reason why New York City is rich in water and also drinkable water, because we live in an ecosystem, or let's call it an ecological state system that has created this type of environments, and then that has helped the United States, and in this case New York City, to become one of the richest cities in the planet. So I mentioned forests. So forests have what we call a ecosystem service. So it's a natural or free service that has no connection to money and value. It's naturally made that provides services to humanity and the planet. So here is according to Pacau and Kinsick 2002, there are three classes of ecosystem functions. Here is its ecosystem function. So what type of function does that system have? So we have three classes of ecosystem function. We have stocks of energy and materials, for example, biomass and genes. Fluxes of energy or material processing, for example, productivity and decomposition. Third is stability of rates or stocks over time, for example, resiliency, predictability. So we have the composition. So that's a ecosystem function. That means you have something called decomposers. So for example, when you do composting, all this compost breaks down, but it takes all these organisms, decomposers, to decompose those fruits, vegetables, and whatever is used for composting. So those are an ecosystem function, right? And then you have all the biomass and also genes and all of these things. According to the group et al. 2002, there are four primary groups of ecosystems functions. They have regulatory functions, habitat functions, production functions, information functions. So do these things mean? So we have regulatory functions. That means that you have ecosystems that regulate things. So they say they could regulate the weather. Uh, for example, you have a desert, and there's no water there. Since there's no water there, there's no evaporation. So there's no rain, right? And then you have lakes, and then the lakes, through their function, it regulates weather patterns in the area because you have evaporation and then it rains. Okay, so it regulates that ecosystem, and they have habitat functions. I mean, some species and some plants, they function in the way that helps that system. And then production function, that means they populate or they produce in a way that is useful for the ecosystem and is also useful for humans, right? So they have a function of production, and they have information functions. So that one I'm a little bit confused about. I don't know that much about that one. Here you have a map of ecosystems types. The green areas are rainforests, right? The dark green areas are rainforests. Light green areas is also forests. And then North Africa is desert, tundra, ice, and rock. This is a map of water use. Green is water surplus, sufficient resources, occasional shortages, water shortages. So you have these continents, and then you have areas like in Africa, there's water shortages. And then areas in North America, you have water surplus. So New York City has a water surplus. And other areas have sufficient resources. But the major ones that have water shortages are in Australia, Africa, in some areas in Asia, and in South America, the west section of South America, Mexico, and the west areas of the United States have water shortages. What is these things being used for? What is the water being used for? It says 49% is used for industry, 41% is used for agriculture, and 10% is domestic. So these industries and agriculture have a dramatic effect on water and how it's being used. So right now I'm going to talk about a couple of ideas to put this all together, to find ways to improve our cities and to think of ways to reduce these problems. It's a daunting task. It's not easy. This is just ideas to start up the conversation. We need more research, more thinking about this, more collaborations with people, more collaboration with groups, and for people to be part of the process and for them to be conscious of their decisions, or to be aware that things are trending in the environmental movement or in the fossil fuel or energy efficiency dialogue. Some of them, to me, most of them do not work. They are meant to maintain the current system. The current system of economics, the current systems of how ecosystems are used, and natural resource use, and mineral extraction, and how water is used. So it maintains the same system. It doesn't change it. So You need to be able to think beyond those systems and think in a different way how these things work and start thinking of solutions. So for me, in the last video, I talked about vertical gardens. I feel vertical gardens are very energy consuming. They consume a lot of energy. They require a lot of energy input from human beings. A lot of these places uses fossil fuel based materials like plastics, uh, use glass, they use all the type of minerals, to construct these things and maintain these things. So to me, it's very energy intensive. So I don't believe that's the solution. The way they are constructed now, that's what I should say. The way they're constructed now, the way they are used, I don't believe that's the way to go. But you could take some of those ideas from there. In here, I just have like a multi-deck area for agriculture, right? So all this agriculture is produced outside of the city. The city in here doesn't grow. I will use the Bronx in this case in New York City and the Bronx. In the Bronx, there's not a lot of land, and a lot of this land is used for development. There's not a lot of open spaces, and also there's not a lot of food production in the Bronx. So there's not a lot of people that grow their own food in the Bronx. A lot of this food comes from other areas in other countries, so they are imported here. So we need to go to the supermarket in order to get our food. So like I said before, transportation, industries, electricity play a role in fossil fuel use. So here it says enough space for species diversity and get enough energy from the sun. Use less highly technical sources, more flora and fauna diversity. And biodiversity tells you that if things are diverse and the way they function and the way things work together makes things resilient, make things adaptable to change, right? And in plants and trees, some trees grow depending on the sun, on the shading of the sun. Some trees grow better when there's more sunlight. Some trees grow better when there's less sunlight. They're shaded trees. And you also have plants. You have agriculture that depends on sunlight. Some grow better in shade. Some grow better in the sun. So this design takes that approach. It takes that approach of ecosystems, of ecology, right? To have a diversity at the top of many different plants. In here, I was only able to put 1, 2, 3, but no, just make believe we have a bundle of plants, bundle of things in one place working together, right? Including bees. Bees are very important. They're pollinators. You need those there, and you need on the top you get all this flora and fauna that are able to live where you have a lot of sunlight. And you have the other layers and then you have species, a diversity of species that are able to withstand the shade. So what does that do? That means when it's diverse, it helps with soil, with the soil. It maintains the soil. A lot of these things that is done in agriculture is a lot of inputs from us, for human beings. We require fossil fuels to maintain these systems. The systems don't maintain themselves because it's not diverse. It's not ecologically sound. It doesn't follow the laws of thermodynamics. If it does, it just follows one way, which is waste. A lot of times it has to do with waste. It's nothing that feeds back that helps the system. So you need to be able to construct the systems that we within themselves is resilient enough that we ourselves don't require fossil fuels, that we don't input energy for ourselves in order to maintain the systems. We only help to manage it because we need to go there to take out the products and the food or whatever it is. but we are working in symbiosis with nature to provide for us as well. So that this is what the sketch is showing. In other videos, I will talk about space. You know, in New York City is a grid. So like I said before, the grid is not helpful for energy, right? Energy use. It's highly energy consumptive. As I gave an analogy of the forest, a forest tends to be continuous. In a lot of these ecosystems tend to be continuous and they're fragmented. They tend to fall apart and they don't have enough diversity that they're able to maintain themselves. So New York City has a grid that requires a lot of fossil fuels, a lot of energy input to maintain itself. So we have to be able to plan for areas. It will not be the same in New York City because the city is already a grid. But in other future places, you have to know the shapes or the areas that need to be developed or where you have agriculture. And for me, I would call it maximum power or put shapes there that maximizes the energy that comes from the sun. And then you use passive housing on top of it and you quantify how much energy you're getting from the natural systems. And here you have to think beyond the regular way. In Botanical Gardens, the weather constructed, I don't believe they are the solutions. We have to work with nature as well, not everything coming from us. You got to let nature help us. I mentioned porosity. In New York City, you have a lot of asphalt, you have a lot of concrete, right? There's no porosity, so the water doesn't seep in. So that affects the groundwater. That affects the water that we're getting to us in other places as well in the region. So these here are pervious papers. So that means the papers and it has these holes and the water seeps in those holes. And then the water seeps in. To me, it would be the best places to have all these ecosystem services, to have all these things helping us as well, is to have a lot of trees. To have a lot of trees, we have a lot of flowers, we have a lot of this flora in these regions, right? One thing that I noticed in New York City design is not a lot of focus on tree placements. What they do, they spread the trees apart, let's say like 12 feet away, and that's it. The function of trees are totally misused in New York City. There's no connection with these trees, there's no connection with the soil. All these trees are in their own island. So to be able to deal with climate change, to deal with EJ, which is environmental justice issues, you have to start thinking how nature does things, right? Continuity, diversity. One thing that I mentioned during meetings is that a lot of these streets tend to look the same because there's not diversity in how they're designed, and there's no connectivity with these trees, right? They are put in their own silos, right? There's no connectivity, there's no flowers between them, there's no other small trees between it, just 5 trees in one block. For me, I would say here is not totally resilient because you have fragmentation, but this is the closest we could get to if we start thinking from an ecological way. All of this provides ecosystem services, and then it helps with EJ issues with air pollution. Like I said before, only 1% of the world's water is drinkable. And a lot of this water in New York City is used to flush toilets for waste use. I forgot to mention, and when you have pavers that don't have any porosity and you have asphalt, the water accumulates on top. It doesn't seep in, right? And through slopes, I mean steepness, or if it is flat, the water you stay there, and then you have evaporation, so it will evaporate. But you have steepness or slopes, the water needs to go somewhere, right? In New York City, there's issues of water contamination because people throw garbage on the floors, and in my neighborhood, dog poop. So when it rains, this garbage drains to water bodies. In this case, the East River, the Bronx River, those areas are contaminated because all this garbage goes there. And then you have issues of waste treatment. So when it rains, the waste treatment plant is not able to handle the amount of waste that's going to the waste treatment plants. So you have CSOs, combined sewage overflow. So those pipes, you take out the waste from the waste treatment plant, and then it takes it to water bodies and rivers. And that creates a lot of environmental problems and marine problems, and many species die in marine ecosystems because of all this waste that goes there and all this trash. So waste, sewage waste, and the waste treated is very important. So here is something called a living machine. A living machine is a way to be able to clean sewage waste locally, right? It uses again ecosystems, so in this case ecological engineering, in order to treat these waste. So you have all these plants, and you have all these species as well, organisms that work together in order to purify and to start cleaning this water, right? Well, these things have limitations. You have gray water, requires a lot of maintenance, and not much water is processed. That means one building could process so much waste that, or produce so much waste that these systems here cannot be able to handle all that waste. And these systems require a lot of space in order to be able to handle, they say, waste of 3 to 4 buildings. But this is just show the how nature is able to purify this water, right? And in the soil layer, it's a building called the soil layer, and also other energy conscious buildings. They do on-site waste treatment. That means the waste, the sewage waste goes to these sections and it purifies it, and then it creates gray water. A lot of people do not like gray water because of the way it looks, but it's, compared to other things, it's cleaner. So what it's used for is to flush toilets. So people don't drink these things. Again, transportation, like electricity, transportation, and industries, as said, are the major sectors, energy sectors. So I myself do not advocate for cars. I believe there should be less cars and it should be smaller. And transportation should be local, and things should be designed in a way that helps people walk shorter distances, and also bicycles show the distances. For me, like I said, I don't advocate for e-bikes. I feel e-bikes are just like another motor. I don't advocate for that. I like regular bikes, right? I know there are issues of people going up the hills, and that's why in other terrain areas, that's why they like e-bikes. I understand that. But according to other things I read and the maps I show me for with the Congo, a lot of these things come from somewhere. Cobalt comes from other countries, so it affects those countries. Unless we are able to help those countries and for them to protect their ecosystems and for them to provide high wages or better lifestyles, I will move away from any high technology or e-bikes. Regular bikes are fine, they still use resources, but compared to the other ones, no, they use less. And you can recycle this metal from other places. So here you have something called a winner. A winner means that many people in many modes of transportation could be used in one area. Right? You have different types. You have the one on the top, which has a car then passing by, so it's the speed is slower, so they slow down in these areas. The bottom one is mainly for bikes, and then smaller cars and bicycles, and then you have for people. So it's multimodal, but it pays more attention to the person instead of the transportation option. For me, I would just say get rid of the car in this section and have more bicycles and have other sections where you have uh, emergency vehicles and trucks that transport products or another way to transport products, and they have light rail in those sections. But in this here, it should be strictly uh, low modal. I would call it low modal, like bicycles, smaller bikes. Maybe in this case, e-bikes. I understand. I don't like it, but I will. In New York City, this might happen more. So uh, I don't know. In this case, I will just here you have more motorbikes. So e-bikes will actually be almost the same thing as this. And they have bicycles, so you can have bicycles here, and there are different types of warners. And in this too, I don't really like some of the things they have here, you know. But this is like an alternative to how things are done today in New York City. So these are just examples of thinking of ways of how we design our places to focus on all these ecosystem services, all these ecosystem functions, or where things are coming from, where things are extracted, biodiversity, how important is to maintain biodiversity in marine and also uh, terrestrial ecosystems. All of these things are important for the survival of the species and the survival of all the species as well, flora and fauna, right? So this is for me to start thinking and also to get more people involved in this conversation about how we should start designing our cities and also thinking of systems or economic systems that is able to transform us in a way that is more sustainable and that balances with nature. Later on, I will talk about other things like economics, politics, design, reality. There are certain realities that we cannot get away from. Now is difficult. Also talk about like there's no such thing as perfection. It's adaptation and changing and modifying things, and other things as well that that will explain in those other elements of systems planning. So leave some comments, and if you have any questions, write it in the comment section. I will do my best to answer them. I am a very holistic person, so I do forget certain information, but I will do my best to answer those things for you. If you have any questions, feel free to ask questions. And also, if you have more information about these things and about ways of designing places, feel free to comment on it, or to provide comments, or and also to provide information. Thank you, and you have a good night. Bye. Bye.